So we're going to learn 3 postulates that prove triangles are similar. Similar to our triangle congruence theorems like AS, but there are different ones that work for just specifically similar shapes. So they won't necessarily be congruent, they'll just be the same shape, but not necessarily the same size. So from yesterday, remember 2 polygons are similar if they satisfy 2 things. Their corresponding angles have to be congruent, and their corresponding sides have to be proportional. Those are the 2 stipulations for similar figures. And then below we have 3 theorems. Now you'll notice that they have a similarity squiggle at the end to differentiate them from the congruence theorems. So the first one is different than any one we've seen before. Remember, angle, angle, angle was not something we were allowed to use. It is something we can use to prove that they're similar, because if 2 angles of a triangle are congruent to 2 angles of a triangle, the third angles theorem would tell you that the third angles are congruent, which will then prove that they're similar. So if, I think this says, I can't shrink this down for some reason, if 2 angles of one triangle are congruent to 2 angles of another triangle, that's enough information to prove that they're similar. So we no longer have to prove all 3 pairs of sides are proportional and all 3 pairs of angles. We can use these shortcut theorems. So since we know angle T is congruent to P and R is congruent to L, based on this postulate, we can say that triangle TRS is similar to triangle PLM. We don't do a lot of proofs with these, but you could, just like we did with triangle congruence. You could prove that the shapes were similar. Okay. The next one is the side angle side similarity, which sounds like the one we've done already, but you have to be careful because the sides are not congruent, okay? The sides are proportional. So if one angle of a triangle is congruent to an angle of a second triangle, and remember, for it to be SAS, it has to be an included angle, so the angle that's in between the 2 sides, including the 2 angles, are proportional, then the triangles are similar. So you'll have to prove that they're proportional. 3 over 6 is 1/2, 2 over 4 is 1/2, those are proportional, therefore the triangles would be similar. So if you know angle A is congruent to angle Q, and you know that the proportions are equal, so that would be, if there weren't numbers there, we would have AB over QR is equal to AC over QS. So we have side angle side, then the triangles are similar. And then the last one is our side-side similarity theorem, which is exactly like it sounds. All 3 sides have to be proven to be proportional to the other. So if the corresponding sides of 2 triangles are proportional, all 3 pairs, then the triangles are similar. So I have this one with numbers. 3/6 is 1/2, 2/4 is 1/2, and 4/8 is 1/2, so they would be similar. If you were doing it without numbers, you would have to have all of the ratios. So AB over QR equals AC over QS equals BC over RS. That's an extended proportion where you have more than one thing. Is that equal? Then the triangles will be similar. I guess we do have like mini proofs. They just say yes or no and why, but you don't have to do a whole 2-column proof like we did in chapter 4. So on the back, are the triangles below similar, yes or no? If so, write a similarity statement and name the postulate or theorem you used. If not, explain. So you still have to add in markings where appropriate, okay? So in this picture, what can I add in that is not there currently? Noah?
Vertical angles congruent.
Good, I can mark my vertical angles are congruent by the vertical angles theorem. If you want, you can mark the other two angles. If you want to use the third angles theorem, you can, but you don't have to. So, do I have angle, angle, side, or side, side, side? Do I have one of those? Yeah. I have two angles are congruent to two angles. So I have angle, angle. Which this one's different than what we did in triangle congruence. So make sure you memorize it as something to identify. So these are absolutely similar. You complete the similarity statement, using your corresponding parts. Remember, how you name the first one doesn't matter. So let's go RSW. Similar, I have the correct symbol this time. 2, you have to match up the corresponding parts, which would be VSB. By, and that would be your angle, angle. I do want you to put a similarity symbol after it just so we know it's not congruence if it's SAS or SSS. If no, explain. Well, it's not a no, so we don't have to explain. Okay, the next one. Can I add in any markings that are not there right now? Do I have any shared sides, shared angles, vertical angles, alternate interior angles? No, there's nothing else that I can add in. But I noticed that it does look like SAS, just based on what's there. But in order for you to say it's SAS, you have to prove the sides are proportional. If they're not proportional, it's not side, angle, side. Okay. So we have to check the pairs of sides. So 3/4 and 6/8. Well, 6/8 reduces to be 3/4, so yes, they are proportional. So we do have side, angle, side, side, angle, side. So this would be a yes. Triangle QRP is similar to XYZ by the side, angle, side similarity postulate. If you were to get that they weren't, one of them was not proportional, so let's suppose this one was 3/4 and this was 6/7, you would say no, and your reason would be that the sides are not proportional. That's usually the reason for no. So the next one, what do we think? Now, looks like side, angle, side, but we would have 6/3, which is 2/1, and 10, and it doesn't matter which way you do this, but I'm going left to right, so 10/4, which would be 5/2. So since these are not equal, they are not proportional, so the answer is no. If it's a no, do not complete the similarity statement because they're not similar. Explain why, which would be that the corresponding sides are not proportional. Are not proportional. Next set of examples, we still have to explain why the triangles are similar. It's no longer a yes, no. They're telling us they are similar, but you do have to explain why. And when it says explain why, you're just telling me which postulate is present. Okay, so you're just picking one of them. Now, you cannot use X as a side length that you know. That's something we're going to prove. So when you're looking at this, you have to only look at the sides that correspond. So the 16 would correspond to the 24, and the 12 would correspond to the 18. And again, I'm figuring that out by the small, medium, large comparison. I cannot say, like a lot of students will say side, side, side for this. but you don't know what x is. So you cannot say you have side, side, side. You don't know what x is. You don't have that side. We can add in vertical angles. And then we should have SAS, but just be sure, 12/18 is that the same thing as 16/24? And if you prefer, you can actually set them equal and cross multiply and make sure they're cross products. Or you can reduce each one. So divide by a factor of 6, we'll get 2/3. Divide by a factor of 8, we'll get 2/3. So those are proportional. So the reason is side angle, side similarity. Then find the value of x. You're basically doing now what we did in our homework last night. We're going to write a proportion and we're going to cross multiply to find out what x is. So for example, let's just use the first one. 12/18 equals 12/18 would equal 10/x. This is one example of a proportion. You also, if you want, instead of using 12/18 with the big numbers, you could use the reduced form. If you'd like. 2/3 equals 10/x. That way you don't have as big of numbers. So we'll get 2x equals 30. So x equals 15. Make sure you answer both questions, why, and then what the value of x is. Example B. First of all, why do we think these triangles are similar? Angle, angle, side, or side, side, side? Marquise? Angle, angle. Most of you will get the value of x. Most of you will, if you get it wrong, you'll get this wrong. People will think, oh, SAS, like SAS, but x is not a side, so you can't use it. So angle, angle, similarity. This is the answer like a lot of, like probably 80% of the time. Angle, angle will be your reason. Then you'll use the fact that they're similar to find the value of x. So see if you can find the value of x. I didn't want to give you the picture for number 3. This part's 3 and this part's s. 3 plus. What do we get?
X equals 16.
No. Should be getting 9. So be careful. Again, you can do a lot of different proportions, different ways, but I would do 8/12. Usually I would reduce it, but I'm not going to. Equals 6/x. You can also do 6/8 if you want, but you have to make sure that you do x/12 and not 12/x. It has to be the corresponding parts. So when you cross multiply, that should get us 9. And you could reduce that too, the fraction, make it a little bit easier. But the last one, a little bit tricky, we have our triangle within a triangle problem. We also have parallel lines, which are interesting. Right now, do we have enough to know that the triangles are similar by angle, side, angles, side, angles, side, 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 angle, side, or angle, angle? Jeremiah? Angle, angle. How? Good. You need to use your parallel lines. And within parallel lines, we have alternate interior, alternate exterior. We have corresponding angles. The corresponding angles postulate told us that if lines parallel, corresponding angles are congruent. So this would be a transversal. Those are in corresponding spots. These are also corresponding angles. So you need to add in those angle markings to be able to say that now I have angle-angle similarity. Once you have similarity, then you can use proportions to solve. Now the biggest mistake I'll see is 5 over 15 equals 3 over x, which is wrong. Okay. Why is it wrong? Well, we have our small triangle that has 3 and 5. We have our big triangle that has 15. And how long is this side going to be? Yeah? No. Close. Maddie? 3 plus x. So think about if I put a number here. Let's say that this was, I don't know, 10. The whole length would be 13, right? 10 plus 3 is 13. It wouldn't be 30. It would be 10 plus 3. So anytime you see two little pieces, you're basically using the segment addition postulate. Remember that from way back when, that you have to add them. So that would be x plus 3. The quantity, x plus 3. So if you want to group it, that might help you. And then we set up our proportion and we cross multiply. So 5 over 15 equals 3 over the quantity, x plus 3. And then the solving just is going to, and you could reduce 5/15. If you want to reduce this to 1/3 to make your numbers smaller, go for it. But cross multiply. Make sure you distribute the 5 to the x and to the 3. Whoops, 45. And then just solve as you normally would. We should get x equals 6. And if you want, you can plug the 6 back in to get 9, and you would be able to verify that 5/15 is 1/3, and 3/9 is 1/3. So you can always kind of check your work and make sure you did it correctly. All right, the last one, I wanted to take the picture off your paper and make you draw it yourself, but it's there, so sometimes they won't be there. So in the sunlight, a cactus casts a 9-foot shadow. If you were to have to draw this on your own, make sure you realize that the shadow would go on the ground. You'd be surprised how many of you would put 9 here. But if you're looking at your shadow, it's actually horizontally on the ground. 6-foot tall person casts a 4-foot long shadow. Use similar triangles to find the height of the cactus. Okay? Now, why would these triangles be similar? This is at the same time of day that they're standing outside. Why would these triangles be similar? Which of those 3 reasons? Be careful. Where am I? It is angle-angle. Okay? It cannot be side-angle-side because you don't know what this side is. Definitely can't be side-side-side because we don't know all 3 sides. Now, you're like, Mrs. Bennett, there's only one angle marked. But why would it be angle-angle, Jeremiah? Good. The sun is at the same height in the air, and it's shining down on you at the same exact angle, which we'll learn later in the year is your angle of elevation or your angle of depression. So if you were thinking about it, both of these angles will be congruent. This one, the angle at which it's kind of coming down over your head, and then also this one would be congruent based on if you were over here looking up at the sun. So those are called angles of elevation and depression. So it would be angle-angle. So see if you can find out what the value of x would be by writing a proportion.